Good day everyone, welcome back into my YouTube channel. This is again your teacher, Sir G. And today's lecture, we will be talking about the second conic section, which is parabola. Now let's proceed to the definition of the parabola. Parabola is a set of all coplanar points that are equidistant from a fixed line and a fixed point not on the fixed line. So if you observe, we have this Cartesian plane here. And the parabola is this set of all coplanar points that are equidistant from this fixed line called the directrix and a fixed point not on the fixed line, which is called the focus. So this thing here is the so-called parabola. And now, let's discuss also the different parts of the curved parabola. The line perpendicular to the directrix and passing through the focus is called the axis of symmetry. So let's see where is the axis of symmetry. A line which is perpendicular to this line directrix and passes through the point focus. The parabola is said to be symmetric with respect to this line. The chord that passes through the focus and perpendicular to the axis of symmetry is called the latus rectum. So that is the line. It passes through the focus and it must be parallel to the directrix and perpendicular to the axis of symmetry. The vertex and the endpoints of the latus rectum of the parabola are used in sketching the parabola. So we need first to get the vertex and the endpoints of the latus rectum of the parabola for us to be able to graph the parabola. And the endpoints of the latus rectum and even the length of the latus rectum will give us how wide or how narrow the graph is. The point on the parabola midway, the latus rectum and the directrix is the vertex of the parabola. So that is the vertex. It is midway between the latus rectum and the directrix. The vertex is the point where the curve changes the direction. See that? A parabola is said to be in its standard position if its vertex is at the origin and its principal axis is one of the coordinate axes. Now, to summarize the different parts to be used in solving the parabola, we use this summary table. A parabola which has a vertex at 0, 0, or the vertex of the parabola is at the origin of the Cartesian plane. So we have here two kinds of parabola. A parabola with horizontal axis of symmetry and a parabola with vertical axis of symmetry. Given the standard equation of the parabola with vertex at 0, 0, for a parabola with horizontal axis, we have y squared is equal to 4px. And for a parabola with a vertical axis of symmetry, it is x squared is equal to 4py. For their focus, a parabola with horizontal axis of symmetry has a focus of p0. And a parabola with vertical axis of symmetry has a focus of 0p. Now, how to get that p? We will discuss that later. For the opening of the parabola, in the parabola with the horizontal axis of symmetry, if the value of p is positive, then the parabola opens to the right. But if the parabola or if the value of p is negative, it opens to the left. For the parabola with vertical axis of symmetry, if p is positive, it opens upward. And if the value of p is negative, it opens downward. So for positive values of p, it's either rightward or upward. For values of p which is negative, it is either leftward or downward. For the latus rectum, for the parabola with horizontal axis of symmetry, we have this equation x is equal to, it's either positive or negative p, and each direction must be vertical, and the length of the latus rectum is 4 times the value of p, or 4p. And their endpoints are the coordinates p, positive, negative 2p. And for a parabola with vertical axis of symmetry, the equation is y is equal to the positive or negative p. Take note, we have y. Direction is horizontal, the length is the same, 4p, and their endpoints are positive, negative 2p, and p. For the axis of symmetry, it's either the x or the y axis. In the directrix, the equation for a parabola with horizontal axis of symmetry, its directrix equation is x is equal to negative p. Just get the negative of the value of p. And its direction, of course, it is perpendicular to the axis of symmetry, so it must be vertical. For a parabola with vertical axis of symmetry, its direction, the direction of the directrix is horizontal, while its equation is y is equal to negative p. Moving on, we have also a parabola with vertex not in the origin, rather it is anywhere in the Cartesian plane, and we will represent that point B at HK. So here are the summary table, or here is, I should say, the summary table of a parabola with vertex HK. So this is the equation, the focus, the opening of the parabola, the latus rectum. Same true with the axis, or for the parabola with 0, 0, vertex. So you may just pause the video and copy the set table for you to master this while answering different examples later. Now, for us to understand further about parabola, let's try this first example, letter A. Given the equation of the parabola, determine the vertex, the focus, the directrix, and the axis of symmetry, and sketch the graph and indicate its corresponding features. So the given, for example, number 1, letter A, is y squared is equal to 16x. Y squared is equal to 16x. The first thing we need to do is to get the value of p. And after getting the value of p, locate your vertex, the endpoint of the latus rectum, for you to graph formally the parabola. If you observe, this form is in the form of y squared is equal to 4px. This is a standard form of the equation of the parabola with vertex at 0, 0. So, we already know the value of the vertex, which is vertex is at 0, 0 because of this standard form. The second thing we need to know is the focus. What is the focus of the parabola? As I've mentioned, we need first to know the value of p. So let's equate that 16 into 4p. So we have 4p is equal to 16, and you need to find or solve the value of p. To do that, let's divide or eliminate that 4 by dividing 4 both sides of the equation. Then we have p is equal to 16 divided by 4 is 4. You got it right. So what then is the focus? Now we need to analyze the given equation. Y squared is equal to 16x. Since we have a quadratic term with the variable y, it is obvious that the parabola is opening its either rightward or leftward. But since the value of p is positive, we are very much pretty sure that the parabola is opening to the right. If that's so, the focus is lying on the x-axis. Therefore, the focus is for
0. We need to write first the 4 before 0 because the focus is lying on the x-axis. Now, how about the value of the directrix? The directrix must be in the form of equation. Since we have a y squared is equal to 16x as given equation of the parabola, the directrix must be a vertical line. Okay, so what do you think is the directrix? Based on the formula, the directrix formula x is equal to negative p. Just get the negative value of your 4. So we have negative 4. X is equal to negative 4 is the directrix. What else? How about the axis of symmetry? As I've mentioned, your axis of symmetry is the x-axis or y is equal to 0. That's the axis of symmetry. What else? How about the endpoints of the latus rectum? Let's try to solve the endpoints of the latus rectum. Now let's also try to graph the parabola for us to indicate the different features of this parabola. That is your x-axis and this will be your y-axis. Now, where is the vertex of the parabola? It is on the origin. It's at 0, 0. How about the focus? The focus is at 4, 0. 2, 3, 4. Let's count. So, this will be the focus at 4, 0. Now, based on the definition, how long is the latus rectum? Yes, the length of the latus rectum is equal to 4p, right? Which is equal to 16. Yes, your 4p is equal to 16. Now, what does it imply? It implies that we need to draw a latus rectum here which is 16 units in length. Therefore, we need to count 8 units upward and 8 units downward to complete the 16 units length. So 1, 2, 3, 4, 5, 6, 7. Let's add more. Then let's get the point here. And what do you think is the point here? We have x as 4 and y as 8. So we have 4, positive 8. And here, 1, 2, 3, 4, 5, 6, 7, and 8. Let's get the point here, which is 4, negative 8. So if we try to draw a chord connecting that point 4, 8, 4, 0, and 4, 8, this chord is the latus rectum, which is 16 units in length. For you to draw the parabola, we just need to draw a smooth curve connecting that point, this point to that point, and don't forget the arrowhead. And yes, that is the parabola. Now let's try also plot or sketch the equation x is equal to negative 4, which is the directrix. So negative 1, negative 2, negative 3, x is equal to negative 4. And this line is called the directrix with equation x is equal to negative 4. So that's how we find the different parts of the parabola, and that's how we graph the curve y squared is equal to 16x. May I just write the endpoints here? We have 4, 8, and 4, negative 8. So this is the endpoint of the lattice, or these are the endpoints of the latus rectum. The second, or the letter B example, is x squared is equal to 12y. Let's find again the vertex, the focus, the equation of the directrix, and the axis of symmetry. And let's try to sketch the graph and indicate its corresponding features. Again, we need to follow the standard form x squared is equal to 4py. Equate that 12 to 4p, equate it that way. Solve the value of p by dividing 4 both sides of the equation. Cancel 4. 12 divided by 4 is equal to 3. So the value of the p is 3. Now, the bonus part here is, of course, you already know the value of the vertex, which is 0, 0, because of that standard form. How about the value of the focus? What do you think is the focus? Now let's analyze the given quadratic equation. X squared is equal to 12y. The quadratic term is in the variable x. Therefore, your parabola could be opening upward or downward. But since the value of p is positive, it is very obvious that the parabola is opening upward. That means that focus is lying on the y-axis. That's why we need to write first the 0 before the 3. So the focus is at 0, 3. How about the equation of the directrix? Yes, the formula for the equation of directrix is y is equal to negative p. Yes, your directrix is y is equal to negative 3. That's the directrix. Now, let's try to graph the parabola and find the different parts of the curve. First, plot the vertex. Second, the focus, 0, positive 3. Okay, the directrix is negative 3, 1, 2, 3. So this is the directrix. Y is equal to negative 3, 0, 3, focus, vertex at 0, 0. Let's find the endpoints of the latus rectum. So there must be 2 coordinates. Our clue here is the value of 4p. What is the value of 4p? It is 12. Divide 12 by 2, that is 6. Meaning, this must be 6 unit length and 6 unit in length to sum up or to get a total of 12 units, which is the length of the latus rectum. So let's count 6 unit. 1, 2, 3, 4, 5, 6. So what is that point? That is 6, 3. So one of the coordinates or endpoints is 6, 3. How about in the other side? 1, 2, 3, 4, 5, 6. That's negative 6. So here, that is negative 6, 3. So one of the endpoints, to complete the endpoints, we have negative 6, 3. Let's connect the 3 points by sketching a very smooth line or curve. And yes, this is now the latus rectum, which is 12 units in length. And this is now the graph of the parabola. So it's very simple. You just need to get the value of P, the vertex, the focus, the directrix, and the latus rectum. How about the axis of symmetry? Axis of symmetry. For the axis of symmetry, it is very obvious that the value of this line x is equal to 0. That will be the axis of symmetry. For the letter C example, we have the given y squared is equal to 10x. If you observe, this is in the form of y squared is equal to 4px. What is the first step? Yes, correct. We need to get the value of p by equating 4p into 10. Solve for p by dividing 4 both sides of the equation. Consider p and the value of p is 10 over 4. Reduce that, get the lowest term, that would be equal to 5 halves. Now, what do you think is the value of the vertex? Yes, the value of the vertex is at 0, 0 because the parabola is in standard position. How about the value of the focus? First things first, we need to analyze the given. We have a quadratic term y squared, meaning the parabola could be opening rightward or leftward only, but since the value of p is positive, we are very much pretty sure that the parabola is opening rightward. What does it imply? Meaning, the axis of symmetry is within the x-axis. So we need to write first 5 halves before 0. You could also rewrite 5 halves into the decimal point for you not to experience difficulty in graphing later. So that would be equal into 2.5. Okay. The third feature we need to get is the equation of the directrix. We have the formula x is equal to negative p. Therefore, the equation of your directrix is equal to x equals negative 5 halves. Now, how about the endpoints of the latus rectum? Endpoints of the latus rectum. Let's try to sketch the curve or the parabola for us to get the endpoints of the said latus rectum. The vertex is at 0, 0. The focus is at 5 halves 0, 2.50. So let's say this is 2, 3, 2.5 there. That's 5 halves 0. That's the focus. The endpoints of the latus rectum, we have length of the latus rectum which is equal to 10, meaning we need to move 5 units upwards and move 5 units downward from the focus. So let's count 1, 2, 3, 4, 5. And what is this point? Yes, of course, that would be 5 halves 5. Then 5 units downward. This is 5 halves negative 5. Then we just need to connect these 3 points to illustrate the latus rectum and connect that 2 points with a smooth curve and these 2 points with a smooth curve, and here that would be your parabola. Now let's rewrite the endpoints. We have 5 halves 5, negative or positive 5 halves negative 5. So those are the endpoints of the latus rectum. Let's also graph the directrix. Negative 5 halves, x is equal to negative 5 halves or negative 2.5. Just label it this way. X is equal to negative 5 halves. So that's the directrix. Now what is the axis of symmetry? Yes, you are correct. the axis of symmetry is the x-axis or your y is equal to 0.
Squared minus 8x plus 6y plus 17 is equal to 0. To the standard form and find the points of the vertex, the focus, the endpoints of the latus rectum, equation of the directrix, and the axis of symmetry. And let's also try to sketch the curve. So the given quadratic or parabola, so the given equation is y squared minus 8x plus 6y plus 17 is equal to 0. So if you observe, this given is in the form of the general form. Now, our main task here is to reduce this form into so-called standard form of the parabola for us to find the different points we need in graphing or sketching the graph of the said parabola. So this one should be in the form of y. The quantity y minus k squared is equal to 4p times x minus h with vertex at hk. So in this form, we can easily pinpoint what is the vertex is. So let's also apply the completing the square for us to arrive in this form. Now let's rewrite the given general form. Y squared, put your 6y beside it, plus 6y is equal to, then transpose the other terms in the right side of the equation. So this would be 8x minus 17. Now applying the completing the square, we need to add a constant value from the left side of the equation and at the right side of this equation. The question is, what is that constant? So we need to get the square of the half of this 6y. So 6 divided by 2 is 3. 6 divided by 2 is 3. Getting the square of that 3, then we get 9. So we need to add 9 both sides of the equation. Next step is we need to factor that out. So that would be y plus 6 divided by 2 is 3 squared is equal to 8x negative 17 plus 9 is negative 8. Now, for us to formally have this form, we need to factor 8x minus 8. We need to move that 8 out. So let's put your 8. So 8x divided by 8 is 1. So just 8, or x I should say. Then 8 divided by 8 is 1. So here, this is now the standard form of the parabola. The question is, what then is the vertex of the parabola? So let's write everything here, the important details about the parabola. First is the vertex. So what is the vertex of the parabola? It should be in the form of hk. So our h here is positive 1 and our k is negative 3. So that's how we get the vertex of the parabola in the form of general form. Of course, you need to reduce it into its standard form. Although there is a certain formula in solving the h and the k of a parabola written in its general form. So this is one of the ways for you to get the value of the vertex. Now, the question is, how about the focus of the parabola? For you to get the focus of the parabola, we need to get the value of p first. Now, how to get the value of p? In the formula, we have 4p there. And what is the value of 4p in this form? Yes, you are right. The value of your 4p is 8. Now, dividing both sides of the equation by 4, now the value of p is 8 divided by 4 is, yes, we have 2. So the value of your P is 2. Meaning, the distance between your vertex to the focus is 2 units. And the distance between your vertex and your directrix is also 2 units. Now, what then is the point of the focus? What is now the coordinate of the focus? What or how to get the focus if the value of P is 2? If you observe, the quadratic term in the said example is the y variable. Meaning, your parabola is opening, it's either opening to the left, your parabola is either opening to the right, or it is opening to the left. But since our P value is positive, we are very much pretty sure that your parabola is opening to the right because your P is positive. Now, what does it imply? It implies that your axis of symmetry must be parallel to your x-axis. Okay? Then, and so what? So then, for you to get the focus, let's graph initially the parabola. First is to sketch where the vertex is. So at point 1, negative 3. It's 1, negative 3. So this would be the vertex at 1, negative 3. Next is to and as I've said, your axis of symmetry is the line parallel to your x-axis. So this is your axis of symmetry. From the axis of symmetry, it is where the line or where your focus is lying. So since the value of your P is positive 2, we need to move 2 units away from the vertex to the right and 2 units away to the vertex to the left for you to get the equation of your directrix. So let's do it. So let's have 2 units away to the right. Since we know that your parabola is opening to the right, then your focus must be on the right of your vertex. So let's count 2 units. It's 1, 2. The question is, what is that point? This would be your focus. At point, we have 3 and negative 3. So we now have this focus 3, negative 3. Next, how about the endpoints of the latus rectum? The latus rectum is a chord that passes through your focus and it must be perpendicular to this axis of symmetry. So let's draw initially your latus rectum, which is a chord. Now, based on our standard form of the parabola, the value of your 4p is 8. And we know that by definition, that 4p is the length of the latus rectum. Now, since we have 8 length of the latus rectum, it suggests that we need to have 4 units from the focus. We need to count 4 units upward and 4 units downward to complete the 8 units length of the latus rectum. So let's do that. So let's count. This is 1, 2, 3, and 4. Then let's have this point. Let's name this point. We have in the x coordinate 3 and we have the y coordinate 1. How about downward? Let's count 4 units downward. 1, 2, 3, 4. So what is this point? Yes, we have 3, negative 7. So we have now the endpoints of your latus rectum. Let's rewrite this one. Endpoints. Endpoints of the latus rectum. We have your 3, 1, and 3, negative 7. Now let's try to get the equation of the directrix of the parabola. So let's go back to the value of P. The value of P is positive 2, and we know that the vertex is lying between your focus and the directrix. So since this is P units away, that is P units away, which your P is equal to 2, so we need also to count 2 units away from the vertex leftward. So let's count. This is your 1 unit, then this must be your 2 units. So from that point to this point, it must have a value of 2, which is your P. The question is, where is the directrix? The line which is perpendicular to your axis of symmetry that passes through that point is now the so-called directrix. And your directrix is the line x is equal to negative 1. Sir, how about our axis of symmetry? That's a good question. The axis of symmetry is the line perpendicular to the directrix that passes through the vertex and the focus. So what is this line? The line that passes through your negative 3. So therefore, your axis of symmetry is y is equal to negative 3. Now to graph the parabola, we have this one. We need to connect your vertex and to one of the endpoints of the latus rectum. Vertex to one of the endpoints of the latus rectum. Then there you have it. We have this parabola already. Okay, for the third example, we have x squared minus 6x minus y plus 11 is equal to 0. Reduce this form in the standard form and find the point of the vertex, the focus, the endpoints of the latus rectum. And let's try to get the equation of the directrix and even the axis of symmetry, and let's graph the parabola. So if you observe again, this one is written in its general form. What we need to do is to write this one into its standard form. Since we have the quadratic term x variable, this must be x. The quantity of x minus h squared is equal to 4p times your y minus k with vertex at hk. Now let's write the general form. X squared minus 6x is equal to, transpose that y term in the other side, we have y, transpose that 11 in the other side, that must be negative 11. Then applying the completing the square method, we have x squared minus 6x plus value is equal to y minus 11 plus a certain value again. And what is that value? Let's divide your negative 6 by 2, and that is your negative 3. Take the square of that, and that would be your positive 9. Now let's factor this out. This is x minus, we have negative 3 squared is equal to, let's add negative 11 and 9, we have negative 2. Now there you have it. We have now the standard
form of the parabola. Now, what is the value of h? The value of h in this standard form is, yes, it's positive 3. How the value of k? It's again positive 2. Now let's summarize the important details about the parabola. Your vertex is at 3, positive 2. Now let's also try to get the focus of the parabola. But before we get the focus, we need first get the value of your p. To do that, let's equate 4p into, well, how long is the latus rectum based on the standard form? Yes, it is equal to 1. So let's equate that into 1. Divide both sides by 4. Cancel 4. Then p is equal to, what's p? It is equal to 1/4. So that's the distance between the vertex to the focus and distance between the vertex to the directrix. Now, moving on, what then is the focus? To do that, let's try again to plot first the vertex of the parabola, 3, 2. We have 3, positive 3, positive 2. We are in the first quadrant of the Cartesian plane. This would be the vertex of the parabola, 3, 2. May I use the red marker for a better visibility? So here, we have the vertex, positive 3, positive 2. Next, since that P is the distance between the vertex to the focus, and we know that the parabola is opening upward. Now, paano ko nasabi yun? Since the quadratic term is the x variable, the variable with the exponent 2 is x. Now, I can say that the parabola is either opening upward or downward. Now, since my p is positive, then I can say that my parabola is opening upward based on the summary table. You may review that one. Now, moving on. So, this p is the distance between your vertex to the focus. So, let's count 1/4 unit away from the vertex upward. Why upward? Because your axis of symmetry, the direction of the axis of symmetry is in a vertical direction. Yan. So let's initially graph the axis of symmetry of the parabola. It must pass through our vertex and of course the focus later. So this is your vertex. Now, let's count 1/4 unit away. This is your 1/2. 1/4 is in this one. So that would be our focus. The question is, what is the value of the focus, or what is the coordinate of the focus? Since they are lying on the same line, they must have the same x coordinate. We have 3. And the problem is, what is the y coordinate? So we have 2 coordinates in the vertex. We just move 1/4 unit away, upward. So we need to add 1/4 into 2, and this would be equal to 9/4. So this is your 9/4. 3/9/4 is the y coordinate of your focus. Next, so we may now write the focus here to summarize the important details. We have 3/9/4. Sir, can we write the coordinates in decimal form? You may do that. It's just okay. Now, let's try also solve or find the endpoints of the latus rectum. Now, to do that, we need to know first how long or how short the latus rectum is. Now, what is the length of the latus rectum?
Yes, it is equal to 1 unit because your 4p is equal to 1. Take note that for you to determine the length of the latus rectum, you must go back to the standard form and find the value of your 4p. Since your 4p here is positive 1, then that's the length of the latus rectum. Now, what does it imply? It implies that from the focus, we need to make a line perpendicular to the axis of symmetry, and it must pass through our focus. So let's draw a simple line here. Then to get the endpoints, we need to move 1/2 away from the focus rightward and 1/2 away from the focus leftward. Why? Just to complete the 1 unit length of the latus rectum. So that's 0.5, that's 0.5. So let's move 0.5 away or 1/2 away. Let's move 1/2 away. So those are the endpoints of the latus rectum. How to find the coordinates? Since we are on the same line with the focus, we must have the same y coordinate. So my y coordinate is 9/4. So with this one, my y coordinate must also be 9/4. The question is, how about my x coordinate? The x coordinate is from the 3, we need to add 1/2 to get my x coordinate here. And that would be equal to 7 halves. So this is 7 halves. How about here? From the 3, I need to subtract 1/2 to get the x coordinate. And this would be equal to 5 halves. 5 halves. So there you have it. I have now the endpoints of my latus rectum, which are 5 halves, 9/4, and 7 halves, 9/4. Sir, how about the equation of the directrix? For us to get the directrix, we need to go back to the value of P. This P is the distance between your vertex to your directrix. So that is 1/4. Let's move 1/4 away from the vertex downward. Since we know that the parabola is opening upward. This is 0.5, that's 1/4. So this one. The question is, what is the coordinate of that? But we don't need the coordinate, but we just need this line, the equation of the line that passes through that point. So what is the equation of this line? Since we moved 1/4 away or 1/4 unit downward from this 2, we need to subtract 1/4 from 2, and that would be 7/4. So the equation of the directrix is y is equal to 7/4. So let's rewrite that one here to summarize the important details about the parabola. It's 7/4. How about the axis of symmetry? The axis of symmetry is the line that passes through the vertex and your focus. And what is this line? The line that passes through this 3. Therefore, your axis of symmetry is equal to x equals to positive 3. Now, let's formally graph the parabola. We need just to connect the vertex to one of the endpoints, and so with the other side, and there you have it. We have now the parabola with vertex 3 to focus 3, 9/4, endpoints of the latus rectum, 5 halves, 9/4, 7 halves, 9/4. The equation of the directrix is 7/4, and the equation of the axis of symmetry is x equals 3. So that's how we reduce the general form equation of parabola into its standard form, and to get the important features of the parabola.